Okay, so number 15 says that z, x, and zy are tangents to circle C at x and y. X, y, z is equiangular. I'm just going to start by marking this as circle C and drawing my tangent lines. Now, do you see that zx and zy are both tangents to circle C at x and y, which means that z is going to be our exterior point because it says it's the points of tangency are x and y. So I'm going to start by just drawing some tangent lines here. Here's my one tangent line. Here's going to be my other tangent line. I'm going to call this x, and I'm going to call this y, and then that makes this z. My circle is C. I also know that my radii are 5. They've given us that information. I know that these are right angles. Ooh, my sketch is a little sketchy, no pun intended. But we know that the point of tangency is perpendicular, so we're just going to have to deal with the fact that the sketch is a little iffy. Okay, now it says that triangle XYZ is equiangular. So, also means it's equilateral, right? That means that XZ equals ZY, which equals XY. Okay, just keep that in mind for later. So we are going to need to find, we need to find quadrilateral CXZY. Well, we know two of the dimensions. We know the dimensions that are both 5 in length. It's the XZ and the ZY that we need. How are we going to find that? Well, we know if this triangle is equiangular, that means this has to be 60, this has to be 60, and this has to be 60. And if that's the case, we can know that this must be 30, right? Because it was a 90-degree angle. So this is 30. We would have already known that because this was an isosceles triangle, right? Can you see that? So I'm going to recommend that we drop an altitude down our isosceles triangle because we can use the 30, 60, 90 triangle. If this is an altitude, that means this is a right angle. And if we would be able to figure out what the blue line's dimension is, xy, we know that xy is equal to xz and zy. So we would be in business because those were the only two pieces we still needed. Okay, so let's see what we can do here. We know this is 60 degrees because this is 30 and this is 90. So we know this is a 30, 60, 90 triangle, and we've been given this dimension as 5. So I'm just going to set up my reference triangle here off to the side, but I'm going to orient my reference triangle the same way that this one is oriented. So this is 30, this is 60, and of course 90. Remember that the 30-degree angle has the square root of 3 with it, 60 degree has 1, and you can see I definitely do not have this to scale because my 60 degree, this side opposite my 60 degree side is yeah, well, it's not a great drawing, but you'll understand. Okay, so now we can say, because this is the leg that we're trying to find. We're trying to find this blue leg right here so that we can figure out what this whole piece is, so we can figure out what zy is and zx, and we'll be in business. So what we're looking for, what we can set up then is we can say 2 is to 5, right? As the square root of 3 is to this segment right here, okay? We'll just call that x, all right? So we've got 2x equals 5 times the square root of 3. Divide both sides by 2. That tells us that x is equal to 5 times the square root of 3 over 2. Well, you know we need 2 of these dimensions, right? Okay? So if we multiply this by 2, that cancels. So we know that that whole blue line, xy, we can confidently say that xy is equal to 5 times the square root of 3. So let's put that right here, 5 times the square root of 3, all right? What we were really interested in, though, is this quadrilateral, well, xz. So now we know we have 5 plus 5 plus 5 times the square root of 3 plus 5 times the square root of 3 equals 10 plus 10 times the square root of 3, and I think the units were, oh goodness, what were the units? Centimeters, okay, and it's a perimeter, so it's just centimeters. Well, I hope that helps.